Hi everybody. In this video, we're going to have another look at an exponential equation within a context. The half-life of radioactive radon-222 is 3.8 days. As the sample of radioactive radon-222 decays, the percentage of radon-222 remaining, P, at any time can be modeled by the function given, where T is the approximate age of the sample in days. We are being asked to algebraically determine the age of the sample. Please take note that if you are asked to algebraically determine a solution, it is essential that you show your algebraic process. So we're algebraically determining the age of the sample to the nearest tenth of a day at which 40% of the original amount remains. So our question mark is the age to the nearest tenth of a day. That's what we're trying to determine. So that would be T, that is unknown, at which 40% of the original amount remains. P is the percentage remaining, so we are simply going to input 40 for P. Sorry, my dog is squeaking his toy in the background. I'm not sure if you can hear that, but sorry for the distraction there. He's having fun. All right, so there's our equation. What we are going to do is isolate the power before we switch forms. So I'm going to divide by 100 on both the right side and the left side in order to cancel the coefficient of that power, which gives me on the left side 0.4. On the right side, I'm going to write the 1/2 as 0.5, and that is raised to an exponent of t over 3.8. Now that I've isolated the power, I can go ahead and switch forms. So switching forms means that we're going to end up with log form because we're starting with exponential form. The reason we're going to switch forms is if we switch from exponential to log form, that will always isolate the exponent. So t over 3.8 will now be isolated. The base of the log will be 0.5 because that's the same as the base of the power. And then the argument will be 0.4. Next, we are going to multiply by 3.8 on both the left side and the right side, which will give me t equals 3.8 times log base 0.5 of 0.4. We're going to go to our calculator in order to evaluate this. So 3.8 times, go into your math menu. If you have one of the newer calculators, you will have most likely this log base option. So if you have it, I would say go ahead and use it. Input the base where it belongs, and then input the argument where it belongs. And then we're going to press enter. We're getting approximately 5.0. We wanted our answer to the nearest tenth. So that's one digit after the decimal, and then the units would be days. If you do not have one of the newer calculators, you can type in 3.8 times log of the argument, which is 0.4, divided by log of the base, which is 0.5 or 0.5. Enter. We get the same answer. So the age of the sample is approximately 5.0 days. All right, everyone, thanks so much for sticking around. See you again.